Hi guys, today I'm going to talk to you about the ice core drilling and the different types of drills used to influence the exploration and development of the Arctic. Ice cores from the cold interior regions of the polar ice sheets provide exceptionally well-preserved and detailed climate records. Therefore, drilling ice cores provides a vital way to go back in time and sample accumulation, air temperature, and air chemistry for another time. In other words, scientists are able to measure the amounts of carbon dioxide and methane changing over time and eventually compare past concentrations of greenhouse gases to temperature. Drilling ice cores can be done using different drills depending on the depth and temperature of the ice. Typically, the types used are mechanical or thermal drills, in which both consist of incising circles around the central vertical core. Mechanical drills are used at sites where the ice is well below freezing, such as the interiors of polar ice sheets. A mechanical drill is simply a rotating pipe or drill barrel with cutters at the head. As the drill rotates, the cutters incise a circle as it descends in the ice. Consequently, the sample of ice is collected in the barrel to drill. Mechanical drills are driven by either a physical source, such as simple hand augers, or with an electromechanical motor drive, such as cable-suspended electromechanical drills. Hand augers are smaller and basic versions of the mechanical drills, which can be handled by man. Its barrel is usually 1 meter long and has a diameter of 3 to 4 inches. The maximum depth to which a hand auger and its extensions can be raised and lowered in and out of the barrel hole by 2 people is about 20 to 30 meters. For greater depths, a mechanical winch or lifting system is required. However, the depths are usually limited by the strength and flexibility of the extension rods to about 40 meters. Thermal drills have similar constitutions as the mechanical drills. However, thermal drills have a ring-shaped end attached to a heating element to melt an annulus around the ice. Melted water is stored in a tank in the drill. Thermal drills are mostly effective when the ice is warmer, that is, when the ice is above -10 degrees Celsius. They are usually used on glaciers of low altitude. For extracting ice cores of larger depth, cable-suspended electrothermal drills come into play. Both cable-suspended electromechanical and electrothermal drills are used when set depths are greater than 40 meters. These drills hang from a cable that runs from a winch over a top wheel on a vertical tower. Hence, electrical wires inside power the drill to allow its operation. Cable-suspended drills are preferred since they significantly decrease the weight of the drill, the amount of power consumption, and time needed to drill. However, these drills have some disadvantages. In particular, electrothermal drills that are used for ice of temperature below -15 degrees Celsius cause a thermal shock in the core, which affects the measurements that are typically made on the specimen. All in all, ice core drilling can be considered one of the vital ways to study the change in Earth's climate and conditions over time. The Arctic ice preserves every experience that the surface undergoes as it stacks over the years. To explore this history, scientists utilize mechanical and thermal drills to store samples. The drills can vary in sizes and functions depending on the situation and type of the Arctic terrain. The drills can be mechanical or thermal. Both types have a cable-suspended model which allows a drill of depth greater than 40 meters to be made. Afterwards, scientists are able to measure and record the change of gases, temperatures, and climates that the terrain has experienced.